All right, so taking a look at the polynomials worksheet today, a couple formulas I want to start with for interior and exterior angles. Remember, the sum of any triangle always have 180 degrees in the interior angles. Any other polygon, so even triangles, the formula we're going to use for the sum of the interior is 180 times n minus 2. Remember, the n minus 2, okay, is actually the number of triangles that we can make, okay? All right, and then we multiply that times 180. So for example, if I have a hexagon for myself here, okay, we've done this before in class, I can essentially draw in and create 4 triangles. So n is the number of sides. It's always minus 2 for the number of triangles. So 6 sides, 4 triangles times 180. And that's where the total degrees of the inside is. Now, if this is a regular polygon, okay, we can figure out each interior angle by taking 180 n minus 2 and dividing it by n. If it's not regular, we can only do the sum. Okay, all the exterior angles, no matter what shape it is, are always going to add to 360. Think about a triangle, like equilateral. Okay, if the angles are all 60, then the exterior angles are essentially going to be 120, and that's where the 360, 120, 120, 120, 360 comes from. Okay, in a regular figure, we can divide by n and get the measure of one of the angles. They haven't asked a lot of questions in that specific formulas, but just so you see some example questions that could show up, here's some examples. So in a triangle, A can range from 50 to 60 and B can range from 90 to 100. Given these conditions, what's the correct range for C? So essentially what we kind of want to do is go for the max and the min here, okay? So if A and C are at their lowest, okay, the smallest they could be would be 50, right, and 90. That would be the small end. And the largest end we could have is A is 60, okay, and C is 100. So somewhere within that range, all right, from the large to the small, and actually those inequality symbols, I think are actually, nope, they're right the first time. Somewhere in there is where angle C, oh, this should be B. B is where angle C is going to be, okay? So if we add these together, right, we add these, we get 140, and we get somewhere in here, we add this, we get 160. So C is going to be some angle where it's 180 minus 140 and 180 minus 160. So we know the range of C has to fall within 180 minus these two numbers. And so if you do 180 minus 40, this is going to leave us with 40 degrees for angle C. And if it's 160, this is going to leave us with 20 degrees for angle C. So we're trying to just doing the max and min here. And so we would choose choice 1. Okay. Number 2, we have a regular, which means all the sides and angles are equal. Octagon, we want to know what x is. So remember, the sum of all of them is 360. We have an octagon, so we just divide by 8. And then 360 divided by 8 is 45. And so we know that this is my answer. All right. One piece of a birdhouse in Adelaide's building in the shape of a pentagon. If A is extended point F, what's the measure of exterior angle here? Same thing, regular. Okay, so I want to do 360 for all of them, divided by pentagon, divided by 5. And then when I divide by 5, because it's going to go in there 72 times. So that's my answer. All right, sum of the interior is 720. How many sides does this have? So we can do our formula. Oh, for some reason we're way up there again. Okay, and I'm going to do 180 n minus 2 for the sum. This is equal to 720. And then a quick easy solution, I can divide this by 180. So n minus 2 is going to equal, quick calculated math here, 4. And so then we just add 2 and we get n is equal to 6. Okay? All right. And if we head over to the next page, these are more questions that they've shown. They've asked a lot of questions on quadrilaterals. So these are the ones from the book you guys have. All right. So we have opposite sides parallel, opposite sides are congruent, the opposite angles are equal, the consecutive angles that are next to each other are supplementary, the diagonals bisect each other. And remember, we can combine these two guys to make one pair of sides. Okay, did it again. All right, that will fix it in a second. One pair of sides congruent and parallel. So don't forget about that one. We're combining those two to get one pair. Okay, rectangles, 4 right angles, diagonals congruent. Rhombuses, 4 sides are congruent, the diagonals are perpendicular, and they also bisect the angles, and a square has all of that stuff. Trapezoid only has one parallel set of parallel sides congruent. The median in a trapezoid is the average of the two bases. And an isosceles trapezoid, the legs are equal, the base angles are equal, the diagonals are equal, and then the opposite angles are supplementary. I'm going to check on that one. We didn't talk about that before, but we'll check on that. So we'll come back to that one in a minute. All right, so just a quick recap. It actually is true. And the reason is because the angles that are next to each other, angle A and B here, okay, these two angles have to add to 180 because these lines are parallel, and angle A and D are equal. So if these two angles are supplementary, then D and B are going to be supplementary, and the same thing with A and C. So that is actually true. So we'll take it, okay? 101. So same thing, we're going to run through the problem. So label everything you know. We know AF and DF are equal. Okay, we know angle R is 124 degrees, and we know this is a parallelogram with Fred right here. So this FRED guy right here is a parallelogram. All right, we're trying to find the measure of angle AFD. So we want the angle up top. So remember, it's a parallelogram. Remember, the opposite angles are equal. And then this is an isosceles triangle, so these two angles are equal. So if this is 124, next door to it has to add to 180 there. So this is 56 and 56. And then we can add the two 56s together to get 112. And we just do 112, right, minus 180. And we should get an answer of 68. And so that's choice number 3. All right, so we're just labeling, and we're trying to figure out all the angles we can from there. In 102, parallelogram is shown below. U and V are points on RS and TS and QR. Okay, so QRST, this guy right here, is a parallelogram. All right, so all those properties we talked about earlier are going to be in play here. Angle S is 60 degrees. Okay, SRT is 83 degrees. So that's this angle right here. And TWU is 35 degrees. We want to know the measure of WVQ. So WVQ, we want to know the measure of this guy down here. Okay? And essentially, what we sort of want to do is focus in on this triangle. I think this is probably the easiest way for us to get there. If I can figure out the measure of this angle next door to WVQ, I can then get that other obtuse angle next to it. So keep in mind that if this angle up here is 60, that this entire angle right here has to be supplementary, so that has to be 120 degrees. And so if we just subtract 83 away, we're going to get 37. So that's the measure of this angle. That's 37 right there. These two are vertical, so this is 35. So 35 and 37, when we add them together, is 72. Okay, and you can actually use the exterior angle theorem and get an answer of 72. But if you want to do 180 minus 72, that's going to be 108, and then 180 minus that will get us to 72 back. So that's going to be our answer. Okay. In 105, parallelogram, once again, LMO, the diagonals are one diagonal is drawn in. If angle M is 118 and angle NLNO is 22, explain why this has to be 40 degrees. So essentially, remember, these two angles are opposite and they have to be equal. And then if we're looking for this angle right here, we can just use the angles in a triangle. So if we're going to explain it, you could draw a little quick proof for yourself, but probably going to be a little more time consuming than you really need to. So just in words, right? Angle O equals 118 since opposite, right? Angles in a parallelogram are equal. And then since the angles in a triangle add to 180, angle L has to equal, and we can just do the math from there, right? 118 plus 22 is going to give us 140, and so angle L must equal, or just say equals 40 degrees, okay? You don't have to get specific. You can do the math on the side if you want and just show that you get 140 and then 180 minus that, but that explanation should be enough, will be enough, okay? Number 107, just some properties here. So based on what we know, what else would we be able to show? So if we know that BE and UL is congruent, what else would we need sufficient to show it's a parallelogram? So only two other options, okay? The first option is that the other two sides are congruent. So we're looking for BL and EU congruent, which does not show up, okay? We have LU in EU, which are next to each other, so that doesn't work. And we have BE and BL, which is next to each other, and that doesn't work. So the other option was that the same two sides have to be parallel, BE and LU, or LU and BE, and so that would be choice 2. BL and EU being congruent wouldn't help in this case, and we'll just undo this. If these two sides were congruent, we have one pair of sides congruent, the other side parallel, that could also be an isosceles trapezoid, where two sides are congruent and the other two sides parallel. So that's why the choice we're going to make here is choice 2. Okay? In 114, if the triangles are congruent, so if triangle ABE is congruent to triangle CFD, and we have that line drawn, then it can be proven that quadrilateral ABCD is a what? So if these are equal, keep in mind that this angle C is going to equal angle A, and if those are equal, that's making our Z. That means that these lines are parallel, right? AB and CD are also going to be equal with CPCTC. We can definitely show a parallelogram. Can you get anything else? Like, can you get the other two sides AD and BC equal? Kind of a stretch here, right? We can get, so we're kind of stuck at that point. We can't get those equal. In order to be a rectangle, we need 90-degree angles, which we don't have. Same thing with square. The best answer here, most appropriate, is going to be the parallelogram. Okay. Number 19, which set of statements would describe a parallelogram that can always be classified as a rhombus, where the diagonals are indeed perpendicular and they do bisect each other? So this is true. They bisect the angles is true, and they form 4 congruent isosceles right triangles. So let's take a look at this. So if we were to draw ourselves a rhombus, okay, best we can, and I draw the diagonals in, okay, remember that these are going to form 4 90-degree angles at the center, okay, and that the diagonals are bisecting. So this is equal to this is equal to this, and since they all have 90-degree angles, they're all going to have side angle side essentially. So they will be true for congruent 90-degree angles, and so we would want to choose choice 4, 1, 2, and 3. All right, and then number 125, the diagonals of the rhombus intersect at the point 2, 1. The equation of the line that contains diagonal TA is that. What's the one that contains diagonal EM? So remember, the diagonals are perpendicular. So if TA is perpendicular to EM, then the slope of TA, right? The slope of TA, which according to the line is -1, has to be perpendicular to the slope of VM. We know the slope is 1. So remember, -1 over 1, opposite reciprocal is +1 over 1, okay? And it's got to go through the point 2, 1. So a couple options. You can just plug this point in here, one for y, 2 for x, and see if it works, okay? And check that it has a slope of 1. Or you can do y equals mx plus b, okay? I can plug this point in, x and y. So 1 is equal to the slope 1 times 2 plus b, and I can solve for b. So if 1 is equal to 2 plus b, I subtract the 2, and I'm going to get -1 is equal to b. And so that's how I also know my equation is going to be choice 1. All right, and it seems like we have another question, and it's not wanting to show. Let's see if we can drag it out. Nope, it's just a random guy. Okay, so that's it. You can check the remind for the other questions to do for homework for the weekend, and I'll see you guys back here on Tuesday. Remember, if you have an exam on Monday, good luck. Otherwise, stay home and rest up. If you're not sure, ask your history teacher today. All right, guys, see ya.